All right, let's take a quick trip back in time, way back to high school geometry class. You remember that feeling, right? Having to prove something that you could already plainly see was true? Well, today we're going to explore the real point of mathematical proof. And I'm guessing it's not what you think.
Oh yeah, we've all been there. You're just staring at a triangle and it's like, obviously those two angles are equal. Your eyes tell you they're equal, but you still have to go through, a dozen tedious formal steps to prove it. It almost always feels like this bizarre exercise in stating the obvious. And that feeling, right there, it gets to the very heart of the problem. We're pretty much taught to see proof as a chore, just a way to confirm something that we already know is true.
Yeah, the way most of us learn it, a proof has one and only one job: verification. It's all about taking a statement and just stamping it with 100% certified true.
But what if that whole quest for certainty isn't really the point? I mean, think about it. Why would actual mathematicians spend months or even years of their lives trying to prove something? There's got to be a deeper, more exciting reason, right? Well, there is. Because the truth is, a proof does so much more than just verify. As we're about to see, it explains things, it shines a light on them, and sometimes it even helps us discover entirely new mathematics we never even knew existed.
So this is the key mental shift we need to make. We need to move away from seeing proof as a tool just for certainty and start seeing it for what it really is, a tool for understanding.
The great mathematician George Polya put it perfectly. He pointed out that mathematicians, they don't start a proof to become convinced of something. No, they start because they're already convinced. The conviction is the starting block, not the finish line.
And this really gets to the core motivation. When you can't prove something you absolutely believe is true, it's not a crisis of faith in the fact. It's a huge flashing sign telling you that there's a gap in your own understanding. And the proof? The proof is how you bridge that gap. So let's explore that first major role beyond certainty, which is proof as the ultimate explanation. It's the tool that finally answers that simple but profound question: why?
And to really get a feel for this, let's use a little story. Picture this. We've got a surfer, shipwrecked on an island that just happens to be a perfect equilateral triangle. The good news is, the waves are awesome on all three beaches.
So our surfer, they want to build a hut. And to be fair to all three of these amazing surf spots, they want to find the single spot on the island where the total walking distance to all three beaches, when you add them up, is as short as it can possibly be. So where are they built? Right in the center? Near one of the corners? What do you think?
Okay, this is where it gets a little weird. If you model this on a computer and you drag a point representing the house all around inside the triangle, you discover something absolutely incredible. The sum of the distances to the three sides, it never changes. It is constant, no matter where you put the house on that island. So now we have a fact. We are completely convinced that this is true. We just saw it with our own eyes on the computer. But we're left with this huge, nagging question. Why? What's the secret sauce? What is it about an equilateral triangle specifically that makes this happen?
And that, right there, is the perfect job for a proof. See, we don't need the proof for more certainty. We're already certain. We need the proof for the insight. It's what connects all the dots and gives us that incredible aha moment of true understanding.
But it gets even better. Proof doesn't just explain what we already know. Sometimes the actual process of proving something can lead to completely new discoveries. So get this, there was a high school student named Duncan Clough, and he was just playing around with some geometric ideas in an equilateral triangle. And he discovered this brand new, really surprising relationship. It became known as Clough's conjecture. Now, here's where it gets really interesting. When mathematicians started trying to prove his conjecture, they found that how you prove it really, really matters. Different methods of proof, different paths, actually unlocked completely different ways to expand on his original idea. This is just a perfect example of proof as an engine for discovery. One clever geometric proof showed that the core idea wasn't just about triangles, it applied to all parallelograms. But then, a completely different algebraic proof revealed that the idea also worked for all equilateral polygons, like the pentagon you see here. The proof wasn't the final destination. It was a launchpad for two totally new mathematical journeys. Now, this richer, deeper view of proof is actually part of a much bigger shift in how educators think about geometry.
a shift away from just memorizing rules and toward genuine understanding. It's based on a theory called the Van Hiele levels. And the idea is actually pretty simple. We learn geometry in stages. First, we just recognize shapes visually. Then, we start analyzing their properties. After that, we begin to see the relationships between those properties. And only then, at level 4, are we really ready to understand a formal deductive proof.
The main takeaway here is that you can't just jump to the end. The real goal of modern math education is to guide students through these levels, building a deep understanding of the why at every single stage before you ever ask them to write a formal proof. The mathematician Viviani, I think, summarized it beautifully. He said the ultimate test of a proof isn't if it makes us more certain, but if it makes us wiser. A good proof should give us a whole new lens to see the world.
So I'll just leave you with this thought. The journey of a mathematical proof, that journey from simply knowing a fact to truly understanding why it's a fact, that's a really powerful one. And it makes you wonder, doesn't it? Where else in our lives do we stop at just knowing what is true, without ever pushing ourselves to discover the far more valuable why?